Hello, everyone. Let's all welcome Jonas Obrist, who's going to talk about purely Python imaging with Pymaging.
Thank you. As he just said, I'm going to talk about Pymaging, which is imaging in Python and only Python. My name is Jonas Obrist. If you want to give me feedback on this talk or just chat with me or check out my other projects, you can head over to my GitHub or Twitter. As my day job, I'm working for a Swiss web agency called Devio on Django CMS and Django CMS related projects. And I'm also a Django CMS core developer, as you can see on my t-shirt. I had the privilege of organizing DjangoCon Europe 2012, or co-organize it. And as probably many in this room, I am a Python enthusiast. However, this is not what we're going to talk about today at all. We're going to talk about processing images in Python. And so there's a little caveat here. I have no idea, or I had no idea, about what a digital image actually is. So I can't code C, and most of the existing imaging stuff out there is C. I can barely get by reading some C stuff, but yeah, as soon as it gets complex like libjpeg, I'm just lost. So yeah, this talk is going to cover on how I went from this state to know a tiny little bit about what images are and how they work, and how we can work with them in Python. So what is Pymaging, or what are the goals of Pymaging? So the goal is to provide a pure Python solution to do common imaging tasks, such as thumbnailing, rotating, scaling, all that kind of stuff. And by common, I mean common for me. Because as long as I'm the only guy working on this, I'm just going to do what I find useful. Once I'm done with that, I'm happy to hear other stuff that people want, or obviously everybody's welcome to help. But so yeah, my goal is to be able to get a PNG or whatever and thumbnail it. When I can do that reliably, I'm happy. And it should be easy installable, so just pip install Pymaging should just work and not require GCC or any headers or all that kind of stuff. Yeah, easy to use, obviously, it's Python, and easy to hack and extend is an important part. And one of the reasons I want to keep it in pure Python, so Python developers can help, and you don't need to know a second language. And obviously, it should support Python 2 and Python 3, because this is 2013. New projects should really, really also support Python 3. Obviously, there is already existing imaging solutions for Python. I guess everybody here is, or most of you here are probably aware of Pill, the Python imaging library, and Pillow, the fork of it. My issue with that is that it's mostly C code and tends to be hard to install. Not so much with Pillow anymore, but it used to be the case back before the Pillow fork happened. So where is Pymaging coming from? The idea of doing something like that or doing crazy stuff like that, yeah, I had it for quite a while, but where it really kicked off was shortly before Christmas in 2011 on the Django CMS Freenode channel. And we were basically discussing how to provide better documentation to install Django CMS on OS X. And one of the things that the Django CMS depends on is Pill. And so we discussed back and forth what is the best way to tell people to install Pill on Mac OS X. Should we just tell them to use Homebrew? Should we tell them to use whatever, to manually install the headers? I don't know. And yeah, and then we were discussing, why is there only Pill? Why is there no alternative? And I was basically wondering, does imaging really depend on the C language? Is there a fundamental reason why this cannot be done in Python? And yeah, Tribal, Chris Kloss, ex-coworker of mine, just said, yes, somebody just has to do it, or we'll never have an alternative. Back at that time, I dismissed that, and The reason for that is because you get, as soon as you whenever I mentioned that we should try this, everybody immediately said it's impossible. It's impossible to do imaging in Python without C. You don't have the libraries, you don't have the format support, et cetera, and it's never going to be fast enough, ever. And yeah, my response to that was immediately PyPy. That turned out to be not the well, so far it's not been the solution to the speed issues. But the other thing is, sometimes speed doesn't matter that much. Whether it takes 1 millisecond to do my thumbnail or 500, because I'm only doing it once, I don't really care. So yeah, despite everybody telling me I should do it and myself telling myself that's not going to ever work, yeah, I tried it anyway. And at this point, a shout out to @KDLava. She picked the name Pymaging. There were a lot of names floating around, and as we all know, naming things is hard. So when you can get help for that, that's wonderful. So yeah, how did I approach the problem? At the very beginning, I tried to do something that I've tried before with moderate success for a completely unrelated project where I tried to port a tiny C library that basically read a binary file into a C struct to Python to do crazy stuff. That was for, just as a little tangent, it was for Counter-Strike Source, so we could write cool add-ons on the server. So I tried that with Pill, just taking a line of C code, looking how I can roughly translate it into Python. Now the problem with Pill is, and with imaging, it's vastly more complex than what I used to do. So it's not just reading bytes from a file into a structure, but you also have to apply filters, decompress, etc. So very quickly, it proved that my C knowledge is just not up to that task, and that it's way too much code to step through and then discard half of it again. So I basically gave up on that and was pretty close to actually giving up the project overall. But then I found the Holy Grail, Google. When I started with it, I obviously Googled like Pill alternatives, Python imaging in Python. And I would get nothing. I would only get Pill sites. But what I should really have done is Google for existing formats. So libraries in Python that can read a certain image format, like PNG, JPEG, GIF. And as it turned out, there's actually quite a few out there. The problem why they're not a Pill alternative is because each of those libraries only supports one format. And sometimes they only support encoding, sometimes only decoding, and they use all kinds of different stuff. So I found PNG, JPEG, and GIF. GIF has a little star because all GIF libraries I could find were in GPL. Now, there's nothing fundamentally wrong with the GPL, of course, but I just happen to prefer the BSD license, and I wanted to keep my code in BSD if possible. So unfortunately, I had to discard those. Maybe a lawyer could tell me that that's not necessary. I don't know. So the next step after finding these was obviously gluing them together. And what was a little bit hard there is that all these libraries most of them were written for a different purpose. Some of them just wanted to extract meta information from images, like the width and height and the color space. They were at different stages in development, and they all used different ways of storing images internally. So a lot of my effort was looking at their decoders, at their encoders, and finding out where I can change stuff so it ends up in the same format across the board. And on top of that, implementing an API that actually works with that image data once we loaded it. So let me quickly talk about how Pymaging actually works. So fundamental approach of Pymaging is that it's all split out across packages. It's not a single monolithic library. So there's a core package, and then there's a package for each format. The core package just provides an API to work with images, but doesn't actually know how to load or save images. That's where the format packages come in. Format package would register itself through setup tool entry points, which I personally find really, really, really cool. Quite a few people in the packaging sphere tell me that they're completely horrible. Not entirely sure why. But for those that don't know, a setup tools entry point is a way for a package to basically tell the Python environment, hey, I have a thing for something. And then another package can ask the Python environment, do you have things for something? And it will get a list of things. In my case, they tell, hey, I'm a Pymaging format, and here's my encoder and decoder. And Pymaging asks, yeah, what formats do I have? And gets those encoder-decoder formats. So the formats don't do anything else than load an image from a file and write an image to a file. The core defines the internal data structure. I'm going to talk about that a little bit more in a minute. And the API to do stuff. So yeah, resizing and everything like that is implemented in the core package. And also some stuff, some basic algorithms to do when you resize it, that it does a nice resizing and that your image doesn't look really broken afterwards. Internally, images are they are now stored in just a flat array. So an array is basically a list. I didn't know about the array module before I worked on this, so I don't know if everybody knows it, but it's basically a list of integers, and all the integers have the same maximum size. And the reason for that is purely performance. Before, it used to be stored as a list of lists. So it had a list, or just list of lists, I don't know. It had a list of rows. And in this list were list of pixels, or a list of colors. That was really nice for me as a Python developer because it made a lot of sense to store the image in per row and then the pixels separate. But it turned out that was just horribly inefficient and just horribly slow. So right now it's just a flat list, and there's this pixel array class that provides you a nice API so you don't have to do math every time you look up a pixel. So you can just say, give me the pixel at XY. It will look in this massive list and find it. Yeah. So where are we at in Pymaging? Formats. It has fairly stable PNG encoding and decoding. It has JPEG decoding, but it's broken. It actually creates really funny images when you load a JPEG, where it will become slightly tilted, and the colors are all off, except for the first row. So there's one byte or bit that is read too much or too little on each line, and funny things happen. It has BMP decoding, so you can read BMPs. I haven't bothered with BMP encoding yet, because why would you want to write a BMP when you can write a PNG? I don't know. And there is, I'm going to butcher that name. I just saw it on GitHub. It's Mikhail Korobov actually implemented some PSD reading. I have no idea how far that endeavor of his is, but I just found it really awesome that somebody would take this really alpha project and extend it with something as insane as PSD. Like, if he just implemented, I don't know, something simpler like GIFs or whatever, I would totally understand that, but PSD was just blowing my mind. The core package has your basic functionality that you would expect, but not much more. So it has resize and crop. That's basically all you need for thumbnailing. It has a pluggable way to tell the resizer how to handle resampling, so how to go from a big canvas to a small one, or the other way around, by looking at the original and figuring out how the looking at the source and figuring out how the target pixel should be. And that is actually quite nice because in PIL you can't do that. In PIL you're restricted to the 3 algorithms they give you. And here you just posit a Python function that does stuff. Thanks to a guy called Craig Dichter, I'm probably butchered that name again, CraigDS on GitHub, we have affine transformations. The really cool thing about that is that I actually don't know what affine transforms are. I know they involve matrices and images, and they do stuff, but he basically forked it, sent me a huge pull request. We actually started on that last PyCon, and it seems to work. His pull requests include tests that pause, so I assume it works. You can rotate pictures. In the beginning, it was just 90 degrees steps. Now you can do it any degree you want. That was also a contribution, I think, from Craig. I'm not entirely sure anymore. You have a basic drawing API. Right now, I only implemented lines, but, well, the drawing API can draw anything. But the helper methods that actually draw useful shapes, currently there's only lines. But that was basically a proof of concept on how to do a shape, and you can do any shape you want. And it supports splitting, which is taking two images and putting them on top of each other, and using transparent pixels, figuring out what the value should be. It does support Python3, because, as you saw, it started in 2011. Python3 was already around. So if you do if you start a new project right now that doesn't depend on anything that has to stay on Python 2, you should really, really, really do Python 3 as well. For this project in particular, it wasn't as hard as I thought. Mostly probably because it's a new project, so I didn't have any legacy code that I needed to port, and because it only ever works with bytes, not strings. So the whole distinction that was added in Python 3, or the whole change with how strings and bytes work, I don't really have to care about it, but because images are always bytes, never strings. So Python 3 is there, so go check it out. Some lessons that I've learned. Imaging is hard, especially formats that aren't PNG. But it's not entirely impossible. Yeah, the whole project right now is not in something you would put into production tomorrow. But as a proof of concept, I think it sort of works. Formats, the different imaging formats, it wasn't really shocking. I expected that, but the level of documentation and specification for each of them varies by a lot. And this is why PNG, I think, is amazing, because their specifications are open on the internet. It's a W3 standard, or an RFC, I don't remember, but it's very easy to read. It's a very simple format. It can do some pretty advanced stuff, but in the basis, it's pretty nice. BMP is super simple. I mean, bitmaps are just basically the image stored on disk, but they're a bit weird. So any other format I looked at stores their pixels from top left, going to the right, line by line by line, until you're in bottom right. And if it's a multicolor picture, it's going to be red, green, blue. Now, BMP is bottom left to the right, all the way to top right, so the other way around. And it stores them in BGR, so blue, green, red, for some reason. So when I first did the BMP encoder, everything worked, but it was flipped and in weird colors. And then I looked at the specs again, and it said, yeah, you have to, it's stored in the other way around. JPEG is really complicated, because PNG just stores it and then does a very simple setlib compression. But JPEG uses Huffman tables and other scary words. And since I've never had a classical computer science education, I have no idea what those words mean. However, somebody I saw recently had a really nice multi-blog post series on how to read JPEG. So during the PyCon sprints, I'm looking forward to going through those and hopefully fix JPEG. GIF is almost easy, but they use LSAT-W for compression, so that's a compression algorithm, but they slightly changed the algorithm so that none of the existing libraries in Python work, and that I can't wrap my head around how to do it. I still hope that I can, at some point, just have this breakthrough, like epiphany in what they actually changed and implemented. Another thing I learned is PyPy is awesome. Now, in this specific case, not because it's faster, because right now, Pymaging runs roughly 10 to 100 times slower on PyPy than CPython. But the PyPy developers were really, really helpful, because they're cool. They treat code that runs faster on CPython than PyPy as a bug of PyPy. So they would look through my code and my benchmarks and provide pointers on how to improve. So they helped me come up with this whole strategy of storing the image in one flat array. And on the other hand, I also helped them to spot performance bugs. And that actually makes me quite proud that there's now like 2 or 3 commits in there that I at least helped inspire. I didn't fix them, but deleting array slices in PyPy is now a lot faster, and you can thank me. And the other really important thing that I found out is you're really not the first one that is doing something. In probably 90% of the cases, somebody has at least attempted it. So Google, and try to be smarter than me in Googling, and you'll find stuff faster. And then just build on the work of others. You don't have to stop after the Googling. You can still try to improve. So yeah, where do we go from here? You might have realized from what I've just told you that this whole thing isn't entirely stable. And the really important things I have to do is fix JPEG, and people actually reported some weird bugs if you rotate pictures and resize them. Sometimes it completely breaks. And another important thing I need to add is delayed loading, which means when you open an image, it shouldn't just read the whole thing, but it just should first read the metadata, then you can inspect it and look at, is this an image I want to accept? And then once you do operations on it, then it should load it. And yeah, if this thing should go anywhere, I pretty much need help. And the important thing here to know is you can probably contribute even if you think you can't. I didn't know anything about it before, so you don't need to be a PhD in computer science or have implemented several JPEG decoders or something like that. Many formats are just documented, and you can just read the documentation and translate this English document or whatever language it is into Python. So ways you can contribute it is pick a format that I didn't implement yet and implement it. Pick a format that I implemented and fix it because I probably have bugs in there. Or just come talk to me and ask me, and especially if you're trying to contribute or look at this project, come ask me if you don't understand it. I've tried to pretty much document everything there is on read the docs, but you might still be a little bit confused why there is 4 different classes for a pixel array. So if you're not entirely sure, ask me. I'm going to be at the PyCon sprint. Probably going to sprint a few days, or at least a few hours on Pymaging. So if you're interested, come talk to me. And with that, thank you for listening. And if you have any questions, I'd be happy to answer them. And here's a list of GitHub links to all the projects that I did with Pymaging. And again, my contact details if you want to give me feedback after PyCon. Thank you.
Any plan to support TIFF?
Sorry?
Any plan to support TIFF?
If I have any plans to support TIFF, I have plans to support every format there is out there. It's a matter of prioritizing. Can I suggest that you look into that?
I'm not sure if your motivation was strictly avoiding C at all costs, and if that's the case, maybe that's a good answer. But I'm curious, why you didn't, or what your thoughts are on the scikit's image project, which is a pretty sophisticated and advanced image processing library in Python written by a big team that does image processing for a living.
Sorry, what was the name of that again?
Scikit image.
I am actually not familiar with that. I probably have to look at that.
Okay.
Is it pure Python?
No, that's why I said that if
Okay.
avoiding C at all costs was your motivation, then that would answer it.
Avoiding C at all costs sounds like I really hate C, but the reason for that is because I don't know C. So I cannot build on top of C because I do not have the experience in it. And the other reason is that as soon as you include C modules in Python, it just gets orders of magnitudes harder to install, especially for new users who are not familiar with what this error means when you run setup.py and it tells you like blah blah blah.h not found. So that's the motivation why I want to stay away from C. But yeah, thanks.
So I had a question. You said that you were storing your imaging arrays as list of arrays. Is there a reason why you don't do just a three-dimensional array like X, Y, Z, and say like numpy or something?
Yeah, there is a reason for that. That's how I initially stored them, and the reason is just performance. Just having a single list, basically, no rows, no nothing, that is all computed when you access it, just makes it a lot more efficient. A lot of operations, especially loading and saving, become so much faster if you do it like that. It's a little bit weird to wrap your head around, but in the end, it's worth it.
Sorry, just I guess a follow-up. Is that just for 3-band images, or do you think that would scale if you were trying to store something that was like 6 bands or?
I'm sorry, could you repeat that?
Do you think, is that just for the 3-band images that you're working with, or do you think that would also be the case if you were trying to store something that had 6 bands, like instead of red, green, blue, that had red, green, blue, alpha, beta, gamma, or additional?
That, I honestly don't know, but I would assume that this also helps if you add more channels. Because right now the format supports like how many channels you want. It is optimized for pixel sizes between 1 and 4 bytes, but there's no reason why you shouldn't be able to add more.
Thank you.
Hi. So you're trying to avoid writing C code, but how about using C libraries with C types?
Using C libraries pretty much requires me to know C. Like, I've looked at how I can call out into C in Python, and pretty much all of that seems to assume I know C. Like, I looked at CFFI from the PyPy guys and the official Python documentation on how to do that, and I just didn't understand anything, to be honest. I think maybe the solution to all my problems is to learn C.
Okay, thank you.
Hello. I'm just curious if you tried playing around with this in Python, because it's a pure Python implementation. That's really cool. I could see that being a hindrance if you were trying to do C types and you want to, deploy to Elastic Beanstalk or whatnot.
Yeah. The idea is that any Python implementation can run this. So right now, CPython and PyPy run it perfectly well. The only reason why IronPython and Python currently cannot run it is because it requires a minimum of Python 2.6 syntax. I didn't support 2.5 because, yeah, it's 2013, I'm sorry. I'm not going to do new libraries that support 2.5. And I would assume that Python and IronPython at some point gain higher Python syntax levels. For Python? Yes. Oh, so apparently there's a 2.7 beta available, so I'll have to check that out. Thanks. And apparently IronPython is also 2.7, so I have to, recheck this. Thanks. So, yeah.